Hi, this paper is a comprehensive survey on image contrast enhancement techniques in the spatial domain. It was written by the following authors and it has been published in this journal called Sense Imaging in the year 2020, and the link can be found in under references. So to start off with, image enhancement is essential for any image processing applications, and its objective is to reveal the hidden information. The quality of the image can be raised by increasing the contrast, and this method is called contrast enhancement, which has found a lot of applications in fields like medical, satellite imaging systems, surveillance, and machine vision. The survey that was carried out in this paper also mentions that these following properties, such as brightness preservation, entropy preservation, and structural information loss, which are part of the pictures, are to be catered as well during contrast enhancement. And to validate the various algorithms in terms of both qualitative and quantitative means, the researchers have used various performance measures such as entropy, which is a standard benchmark for evaluating the various algorithms. This paper has also used a lot of pictures from different databases such as Columbia, CSIQ, and USC SIPI in order to test and validate the algorithms and compare between them to see which one is the best among them. So here the global histogram equalization method is defined as follows mathematically, and it is abbreviated as GHE. HK refers to the intensity at the kth level, and this is represented by the in number of occurrences of that particular kth intensity in the entire image. And the probability of that intensity level is defined as the number of occurrences of that intensity level divided by the entire size of the image, which is defined as m into n, or length times breadth. Ck is the CDF function, which is calculated by adding up all the probabilities from 1 to L, which are distinct intensity levels. And Yk is the mapping function for which the original histogram is then transformed using the CDF CK, and the XL and XO are the minimum and maximum intensities of the input image respectively. So this is the final output that's generated from the equalization, and if the transformation has flat regions that are all outputted to the same value, which is the same gray value, so it's a many map to a many to one mapping. So this leads to a gray level loss and essentially creates gray level compression, and because of this, inverse mapping cannot be possible. So these are some of the performance measures that the paper has considered, such as the entropy, the mean, AMB, which is the absolute mean brightness error, the contrast, CII, which is the contrast improvement index, and the CLOC is defined as follows. Then the PSNR, which is the peak signal to noise ratio, and the GMSD defined here, which is the gradient magnitude similarity deviation. So all these performance measures have been used to see and compare all the different images that have been resulted from the different contrast enhancement techniques used on images. So these are all the enhancement techniques that have been used on 3 different images from 3 different databases, which have been mentioned earlier. And these, the first is the test image, obviously, that corresponds to these over here. Then B to J refers to the enhancement techniques that have been applied on the image, and the test image is a low contrast image that has been considered. So the techniques from B to G are the bihistogram technique, and H to J are the 2D histogram technique, which have been mentioned earlier. It starts off with BBHE and goes up till EEBHE, which is the edge enhancing bihistogram equalization using the guided image filter. And the first one is a simple brightness preserving bihistogram equalization, which preserves the mean brightness of the image while contrast is enhanced. Then we have 2DHE, which is a two-dimensional histogram equalization, and it moves up to the residual SECET, which stands for the Residual Spatial Entropy Based Global and Local Contrast Enhancement, which considers both of these equally. So moving on to the actual results that were obtained by applying different contrast enhancing algorithms on the test images as shown. Let's first classify them based on the method. So the first method, A to G, corresponds to the bihistogram method, and H to J corresponds to 2D based method. From all of these pictures, we can see that the ith class of images have the highest contrast, and this corresponds to the SECEDCT method. And we can also observe that some artifacts are present near the edges of the pictures. The image D in the same class of images has has significantly better contrast, and that corresponds to ESIHE. It also has a really high CII, and contrast values, which is also prevailed in the ith class of images. In G, we have edges which are retained due to the usage of guided filter. Since EEPHEGF uses a guided filter, it has a better SSIM, DEN, and GMST values than the rest due to guided filter, which preserves the structural information. Another thing to note is that the CII value is generally found to be higher for 2D based methods corresponding to HI and J, as it uses neighborhood information and spatial distribution to improve contrast in their local regions. So these are some charts that were generated for the different quantitative measures such as AMPE, entropy, and PSNR for the images that were considered, such as the first one, the second one, and the third one. And the various methods are shown as M1 till M9. Now among these, ESIHE, which is the third method, and EEPHEGF, which is the sixth method, has the better mean preservation compared to the other methods in the sense that it gives a similar value for the different kinds of images. EEPHEGF also has the highest entropy in this case, and 2DHE, which is M7, has the better PSNR value compared to the rest. Now, EEPHEGF and residual SECEDCT obtained the best qualitative values from different observers compared to other methods in which a rating was given for those kinds of images. So most of the observers have given it a rating of 4, and the other images didn't get that great of a rating, giving EEPHEGF and residual SECEDCT, which is M9 and M6 correspondingly, having the best quantitative and qualitative values compared to the other enhancement techniques. So EEPHEGF produces a better result in terms of brightness preservation, discrete entropy, preservation of the structural information, and image perceptual quality. 2D methods resulted in better contrast improvement in terms of CII, SO, and contrast, which refers to the residual SECEDCT method. So to conclude what we have discussed so far, this paper provides various contrast enhancement algorithms from traditional to recent techniques that have been discussed, and each of these enhancement techniques have its own advantages and can be suited for various applications based on the specific user requirement. For further research, numerous methods can be combined, and this not only enhances the contrast but also preserves information content, mean brightness, and prevents loss of structural information. According to the applications and nature of the image, the proper enhancement technique can be utilized to achieve a high contrast image. Thank you.